हरे कृष्णा. आज गुरुपौर्णिमा. गुरुपौर्णिमेच्या सगळ्यांना हार्दिक शुभेच्छा. I am continuing again the application of a derivative and the fourth application, that is the Rolle's and the Lagrange's mean value theorem. In the last session we have studied the first application, that is the tangent and normal. The second application, that is the rate measure. The third application we have studied, that is the approximation. You have to find out the approximate value of a functions, isn't it? So the different type of a functions are there: the algebraic, trigonometric, inverse, and the inverse trigonometric function, and the exponential and the logarithmic function that we have studied in the last session. Now today I am going to start, that is what here, the Rolle's and the Lagrange's mean value theorem. Now what do you mean by the Rolle's theorem and what do you mean by the Lagrange's mean value theorem? So here, for the Rolle's theorem, there are the three conditions. Every function must be continuous. Suppose y is equal to f of x, it is the any function and it is defined where the x belongs to the closed interval a comma b. Suppose they have given the function and where the x belongs to the closed interval a comma b, then your function, whatever the function they have given, that must be continuous in the closed interval a comma b. Whatever the interval they have given, that must be continuous in a closed interval. The second condition, it must be differentiable in an open interval a comma b. What is the first condition here? Your function must be continuous in the closed interval a comma b. Then the function, same function, it must be derivable or differentiable in an open interval a comma b. And the third important condition, that is if f of a is equal to f of b, f of a is equal to f of b, then the condition of a Rolle's theorem gets satisfied. Which these are the three conditions? Our function must be continuous in a closed interval a comma b. It must be continuous in an open interval a comma b. And the third condition, that is if f of a is equal to f of b, then and only then the condition of a Rolle's theorem gets satisfied. And if once the condition of a Rolle's theorem gets satisfied, then there exists a point C belongs to open interval a comma b such that f dash c, it is equal to 0, right? This is about the condition of the Rolle's theorem. When the Rolle's theorem gets satisfied, our function must be continuous in a closed interval. Our function must be differentiable in an open interval a comma b. Again, if f of a is equal to f of b, then and only then if these three conditions get satisfied, then and only then the condition of a Rolle's theorem gets satisfied. And if once the condition of a Rolle's theorem gets satisfied, then there exists a point C belongs to the open interval a comma b such that f dash c, it is equal to 0, isn't it? Now the question is, every time how will you prove the function becomes continuous or it is continuous? Because again there are the three conditions for the continuity. The limit of a function must have to be exist. The value of a function must have to be exist. And if the limit of a function must be equal to the value of a function, then and only then the function is continuous, isn't it? Therefore, again the question is, how will you prove the continuity of a function, isn't it? Again you have to prove the theorem. That is not the matter here, because in general every function, it is continuous in their respective domain. Why? Because on the ground of their graph, if you consider the linear function, then the graph of the linear function, that is always a straight line. Is there any gap in the straight line? No. The straight line, it is continuous, therefore that function is continuous, isn't it? Now if you see any quadratic or the cubic function, you will get the type of a curve like this, isn't it? Some type of a curve you will get. The curve, there is no gap, it is also continuous. If you see the sine function, the graph of a sine function, that is like this. Again there is a continuity in the graph, hence the function is continuous. Therefore all the functions, suppose you consider the cos function, then it is the graph of this cos function, it is like this. Again this function, it is also continuous, isn't it? Exponential function, logarithmic function, they are always continuous in their respective domain, isn't it? Only there is a one function, that is the step function, whose graph is like this. there is gap and gap only, isn't it? Only except this function, that is the step function f of x is equal to, you can write, this is the step function, that is f of x is equal to x in bracket, a square bracket given as a x, and this is called as a step function. And the graph of this step function, नावातच सगळं काही आहे, the graph of that step function, it is just like a step, hence this function, it is not continuous, right, in the given interval or in the given domain, isn't it? Therefore all the function generally they are continuous, quadratic, or you can say cubic, or you can say the every polynomial function it is continuous, the every trigonometric function it is also continuous, the logarithmic and the exponential functions are also continuous, since their graph are continuous. Only there is a step function that is not, it is not continuous, because it graph it is not continuous, isn't it? So no need to no need to any obstacle in that, isn't it? Therefore directly whatever the functions they have given, whether it is a exponential, whether it is a trigonometric, whether it is the polynomial function, you have to directly write as a, this function it is continuous in the given domain, right? Now you know how will you find out the derivative? If it is derivable, you can find out the means you can judge it is whether derivable or not from the given function. Suppose if you can able to find out the derivative of a given function, then the obviously the given function it is derivable. Therefore in every example you have to blindly write as a the given function. Some examples are there, you can't find out the derivative, or the derivative in the given interval it must be again, it may be that is undefined, or you can't find out the derivative, isn't it, in some example. But in general example the functions are given continuous as well as what here derivable. Only the third condition, it is very important, that is f of a is equal to f of b. If f of a is equal to f of b, then and only then the condition of a Rolle's theorem get satisfied. And once the condition of a Rolle's theorem gets satisfied, then there exists a point C such that it is belongs to a comma b, such that f dash c it is equal to 0. Now see the geometrical interpretation of this here. First write down the condition of a Rolle's theorem. Now if y is equal to f of x, where x belongs to a comma b, now here f of x must continuous on closed interval a comma b, it is differentiable on open interval a comma b. And the third here, if f of a is equal to f of b, then condition of Rolle's theorem get satisfies, right? Therefore there exists a point C belongs to the open interval a comma b, such that f dash c it is equal to 0, isn't it? So f dash c is equal to 0. Now see the geometrical interpretation. See here. Suppose y is equal to any function and whose graph is like this, isn't it? The graph of this function it is like this, isn't it? Now this is bounded in a closed interval a comma b, right? X is equal to b. There exists a point C in between, there exists a point C at which the f dash c is equal to 0, isn't it? Therefore suppose you draw the tangent at this point, then the slope of this tangent at the point C, that is the f dash c, it is nothing but the slope of a tangent, and the slope of a tangent you have got as a 0, isn't it? Now you know the slope of a x-axis it is also equal to 0, the slope of x-axis is always 0. Therefore, the tangent at the point C, it is always parallel the tangent at point C, which is parallel to what, x-axis, because the slope of a tangent which is drawn at the point C, it is equal to 0, and you know the slope of a x-axis, it is also equal to 0. Therefore, the tangent at the point C, it is always parallel to what, x-axis. So this is the geometrical interpretation about what, this Rolle's theorem, isn't it? So this is about the Rolle's theorem. So in the Rolle's theorem, the three conditions must have to be satisfied. Which is that condition? It must be continuous in a given interval, closed interval a comma b. It must be differentiable in an open interval a comma b, isn't it? Then the third condition, that is f of a, must be equal to f of b. If the three conditions get satisfied, then the condition of a Rolle's theorem gets satisfied, and once the condition of a Rolle's theorem gets satisfied, then there exists a point C belongs to this open interval a comma b such that f dash c is equal to 0. Now if you try to draw the tangent at the point C, the slope of a f dash c, that is nothing but what, your slope, because the dy by dx, it is nothing but the slope of tangent, right? Again, that is f dash c, f dash x, it is the slope of a tangent. Therefore f dash c, it is also the slope of a tangent at the point what, here C, isn't it? Therefore the tangent at the point C, whose slope, it is always equal to 0, and you know the slope of a x-axis, it is also 0. Therefore the tangent at the point C, it is always parallel to what, here x-axis, and this is the geometrical interpretation about the Rolle's theorem. Now I am going to take examples on what, here Rolle's theorem. See some examples. Now let us take a simple example. Check the first question, that is the check the validity of the Rolle's theorem for following function f of x square minus 4x plus 3, x belongs to 1 comma 3, isn't it? No, see, very simple. Again, if you see, observe this, f of x is equal to x square minus 4x plus 3 is a polynomial function, hence continuous on 1 comma 3, isn't it? Also, it is differentiable on open interval 1 comma 3, means you can find out the derivative at the point in between what, here 1 and 3, isn't it? Now let us find f of 1. F of 1 means what, here 1 square minus 4 into 1 plus 3, isn't it? Again 1 plus 3, 4, 4 minus 4, 0. Again f of 3, 3 square, that is equal to 9. Again 3 square, right, 3 square, 4 into 3 plus 3, 3 square 9, again 12 plus 3, isn't it? Therefore 9 plus 3, 12, and 12 minus 12, 0. Again the function, it is continuous, it is differentiable, and the third condition, that is f of 1 is equal to f of 3. Therefore the validity validity of the Rolle's theorem gets satisfied here, isn't it? The Rolle's theorem, it is valid because the three conditions already get satisfied, isn't it? Now I will take the another problem, simple ones here. The second one, suppose they have given as a f of x is equal to e raised to minus x and sin x. Again, x belongs to 0 to pi, isn't it? Now again, if you observe this, f of x is a exponential and trigonometric function, hence continuous on the closed interval 0 to pi, right? It is also differentiable on 0 to pi, isn't it? The open interval 0 to pi. Again, f of 0, we want to find out f of 0, means e to the power 0 sin 0, e to the power 0 1 sin 0 0. Again, f of pi, that is e to the power minus pi sin pi. The value of a sin pi is always equal to 0. Therefore, f of 0 is equal to f of pi. Therefore, the condition, that is the condition of a Rolle's theorem, it should be continuous, it should be differentiable, and f of 0 is equal to f of pi. Therefore, this function, it is valid, or the validity of a Rolle's theorem get satisfied, isn't it? The Rolle's theorem, it is valid for whatever the function they have given, isn't it? Very simple questions are there, that is the validity, isn't it? Again, see another one, the third, 2x square f of x is equal to 2x square minus 5x plus 3, x belongs to 1, 3. Very simple. Again, this is the polynomial, or you can say the quadratic function. Again, f of x is a polynomial function, hence it is continuous on closed interval 1, 3. Right? It is differentiable on open interval 1, 3. Let us find f of 1. F of 1 is equal to 2 1 square minus 5 plus 3. Therefore, this is equal to 0. F of 3, it is equal to 2 and 3 square minus 5 into 3 plus 3. 3 square 9, 9 to the 18 minus 15 plus 3, isn't it? Now 18 minus 15, that is equal to 3. 3 plus 3, it is equal to 6, isn't it? Therefore, f of 1 not equal to f of 3. Therefore, the Rolle's theorem does not get satisfied here. This is about the third one. Again, I will take fourth one. See, fourth, they have given as a sin x minus cos x plus 3, x belongs to 0 to 2 pi. See here, again f of x is equal to sin x minus cos x plus 3 is a trigonometric function, hence continuous on closed interval 0 to 2 pi. Right? It is differentiable on open interval 0 to 2 pi. There again, we want to find out f of 0. F of 0 means sin 0 minus cos 0 plus 3. Sin 0 0, cos 0 1 plus 3. 3 minus 1 2. Again, we want to find out f of 2 pi, sin 2 pi minus cos 2 pi plus 3. Again, sin 2 pi, that is sin n pi, it is always equal to 0. Sin 2 pi, the value of a cos 2 pi, it is always equal to 1. 1 plus minus 1 plus 3, again 2. Again, f of 0 is equal to f of pi. Therefore, the condition of a Rolle's theorem get satisfied, right? Now, the another type of a question I will take here. See, very simple questions. Second one, given an interval, given an interval a comma b that satisfies hypothesis of Rolle's theorem for the function f of x is equal to x to the power 4 plus x square minus 2. It is known that a is equal to minus 1. Find value of b, isn't it? Now given an interval a comma b that satisfies the hypothesis of the Rolle's theorem, since in the given interval satisfied the hypothesis of a Rolle's theorem for the function, that is what here this function satisfies the hypothesis of a Rolle's theorem, means this function satisfied all the conditions of a Rolle's theorem. Therefore from this you can conclude that since f of x is equal to x raised to 4 x square minus 2 satisfies condition of Rolle's theorem in closed interval a comma b, therefore f of a is equal to f of b, right? Now f of a means a raised to 4 a square minus 2, f of b means b to the power 4 b square minus 2, isn't it? Therefore here what is the value of a they have given, that is minus 1. Therefore minus 1 to the power 4 minus 1 square minus 2, it is equal to b raised to 4 b square minus 2. Again minus 1 to the power 4 1, again minus 1 to the power 2 1, again minus 2, that b to the power 4 b square minus 2. Here this get cancelled, you have got that is b raised to power 4 plus b square minus 2, it is equal to 0. Can you find out the factor? You can find out the factor, that is 2 ones are 2, isn't it? Therefore here you can find out that is 2 ones are 2, b to the power 4 2b square minus b square minus 2, it is equal to 0. B square you can take common, again b square plus 2, here you can take minus 10 common, b square plus 2, it is equal to 0. Again here you have got b square plus 2 and b square minus 1, it is equal to 0, isn't it? Therefore b square plus 2 cannot be equal to 0 since we have got an imaginary number, because b square, suppose you consider minus 2, then b is equal to plus minus root of minus 2, and the root of minus 2, it is nothing but the imaginary number, that is root 2i, isn't it? So this is not the work here, that is b square plus 2 not equal to 0. Here b square minus 1, it is equal to 0, b square is equal to 1, therefore b is equal to plus minus 1, isn't it? Now here they have given the interval a comma b, that is the positive here, the value of a they have given as a minus 1, therefore here you have got the values of a b, that is equal to because here if you observe this, if you substitute, see here, if you substitute that is the value of a b, it is equal to 1, then this satisfied, if you substitute the value of a b, it is equal to 1, then this satisfied what here, that is the here this satisfied the given function, hence the value of a b, it is equal to 1 you have to consider, isn't it? Because b is equal to 1 satisfied because this is one of the root and this satisfied the given function, hence the value of a b you have to consider it as a 1. This is about the second type of a example, isn't it? Again, verify the third type. Say the third type. Verify. Rolle's theorem. Rolle's theorem for following function. Following function. First, f of x is equal to sin x plus cos x plus 7, where x belongs to 0 to 2 pi. Isn't it? Now see here, again f of x is equal to sin x plus cos x plus 7 is a trigonometric function, hence continuous on the closed interval 0 to 2 pi. It is also differentiable on open interval 0 to 2 pi. Again f of 0 is equal to sin 0 plus cos 0 plus 7. Sin 0 0, cos 0 1, 7. This is equal to 8. Again f of 2 pi. Sin 2 pi plus cos 2 pi plus 7. Again sin 2 pi 0, cos 2 pi 1. This is 7, 8. Again f of 0 is equal to f of 2 pi. Isn't it? Therefore, since it is continuous, it is differentiable, and f of 0 is equal to f of 2 pi. Therefore, the condition of Rolle's theorem gets satisfied. Therefore, there exists a point C belongs to, that is 0 to 2 pi, such that f dash c, it is equal to 0. Now you know f of x is equal to sin x plus cos x plus 7, isn't it? Now f dash x you can find out the derivative of a sin x, that is equal to cos x, the derivative of a cos x, that is equal to minus sin x, and the derivative of a 7, 0, isn't it? Therefore f dash c, it is equal to cos c minus sin c. But f dash c, it is equal to 0. Therefore cos c, it is equal to sin c. Therefore c is equal to how much? That is pi by 4, isn't it? And this pi by 4, it is belongs to what here? 0, 2 pi. Right? This is the verification. In this way, you can verify the Rolle's theorem. Since the condition of a Rolle's theorem gets satisfied, there exists a point C belongs to the open interval 0, 2 pi in such a way that f dash c is equal to 0. Therefore, what you have to do? First, you have to find out the derivative of the given function. You can find it f dash x. Now you can find f dash c. This x you have to replace with c. Therefore, here you have got cos c minus sin c. It is equal to 0. Cos c is equal to sin c. Therefore, what is the value of a c here? That is pi by 4. Because the cos pi by 4 is equal to sin pi by 4. What is the value of a cos pi by 4? 1 by root 2. What is the value of a sin pi by 4? 1 by root 2, isn't it? Therefore, c it is you have got as a pi by 4, and which is belongs to, this must be the value of a must belongs to what here? The open interval, that is 0 to 2 pi. Whatever the interval they have given, it must have to be included, isn't it, in that interval. So this is about the verification. That is the third type. See here, the third type. Again I will take f of x is equal to sin x by 2. X belongs to, again, 0 to 2. See here, this problem. Again f of x is equal to sin x by 2 is trigonometric function, hence continuous, hence continuous on closed interval 0 to 2 pi, isn't it? It is differentiable on open interval 0 to 2 pi, right? Now f of 0 sine 0 0 f of 2 pi again sine 2 pi divided by 2, 2 to get cancelled, again you have got sine pi, and the value of a sine pi, it is always equal to 0. Therefore f of 0 is equal to f of 2 pi. Therefore the condition of Rolle's theorem get satisfied. There exists point C belongs to the open interval 0 to 2 pi such that f dash C it is equal to 0, right? Now again, what is given here? The f dash x they have given as f of x is equal to sine x by 2. Now how will you find out f dash x? F dash x it is equal to sine u, that is cos x by 2. The derivative of x by 2, that is equal to 1 by 2, isn't it? Again f dash c it is equal to 1 by 2 cos c by 2, isn't it? Now you know f dash c is equal to 0. 1 by 2 cos c by 2, it is always equal to 0. When you divide it with 1 by 2, here you have got cos c by 2, it is equal to 0. Now what should be the value here? For which the cos function, the cos x, it is always equal to 0, right? The cos x it is always equal to 0 for x is equal to 2n plus minus 1 into pi by 2, where n belongs to the x is equal to, suppose, 2n plus minus 1 into pi by 2, isn't it? Therefore for pi by 2 it is always equal to 0. Therefore c by 2, because pi by 2 it is belongs to what here this, therefore you have to consider pi by 2. Therefore c by 2 it is equal to pi by 2, 2 to get cancelled. What is the value of a c? Pi, and which is belongs to 0 to 2, the open interval 0 to 2 pi, isn't it? Right? Or you can say another value also, you can take from this the different values, but that must be within the given interval, right? Suppose you consider again one of the values, that is suppose you consider 5 pi by 4, isn't it? That is cos c by 2, it is equal to cos, you can write here, that is c by 2, it is equal to 5 pi by 4. Suppose this is c is equal to 5 pi by 4, again you will get 5 pi by 2, right? This cos function takes the value 0 for what here? The odd number of a pi by 2, isn't it? So 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2. Again if you consider 5 pi by 2 here, that is you have to consider the value of a c, that is equal to what here? 5 pi by 4. Then and only then you will get here the 5 pi by 2. Then also it is equal to 0. Therefore from this you have to find out the different value, right? And that must be belongs to what here? The interval, that is 0 to 2 pi, isn't it? So because the cos function it is always equal to 0 for n pi by 2, but n should be odd, therefore the cos it is equal to 0 for 5 pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2, isn't it? Now here again the another one, third one here, verification. F of x is equal to x square minus 5x plus 9, where x belongs to 1, isn't it? Now again f of x is equal to x square minus 5x plus 9 is polynomial function, hence continuous on closed interval 1, 4. It is differentiable open interval 1 comma 4. Again f of 1, it is equal to 1 square means 1 minus 5 plus 9. 9 minus 1, 10. 10 minus 5, 5. Again f of 4, that is 4 square means 16. 5 4s are 20 plus 9. Again 16 plus 9, 25. 25 minus 20, again 5. Again f of 1 is equal to f of 4. Right? Therefore, condition of Rolle's theorem get satisfies. Therefore, there exists point C belongs to open interval 1 comma 4 such that f dash C, it is always equal to 0, isn't it? Here f of x is equal to x square minus 5x plus 9, f dash x, the derivative of x square, that is 2x, and the derivative of a minus 5x minus 5. Again f dash c, it is equal to 2c minus 5, and f dash c is equal to 0. Therefore 2c is equal to 5, c is equal to 5 by 2, and this is nothing but 2 by 5, which is belongs to what here? 1 comma 4. Right? So this is about the verification, right? Verification of a Rolle's theorem. Again, I will take a very important example, that is, see, if f of x is equal to x cube plus px square plus qx plus 5, x belongs to 1 comma 3 with c is equal to 2 plus 1 by root 3. Find p and q if Rolle's theorem get satisfies, isn't it? P and Q, here you want to find out P and Q, isn't it? And they have given as a C is equal to 2 plus 1 by root 3. Now see this example here. This is again very, very important example. Right? You may ask in the board CET, any year, right? Any entrance examination or the board also. Now here the condition of a Rolle's theorem gets satisfied. Means it is continuous, it is differentiable, and the last condition, that is f of 1 is equal to f of 3, that is very, very important, isn't it? Now here since Rolle's theorem hold, therefore you can write for the function f of x, therefore f of 1 is equal to f of 3, isn't it? Now f of 1 means what here? 1 cube, p 1 square, again q into 1 plus 5, right? Again this is 3 cube plus p 3 square plus q 3 plus 5, isn't it? Now 1 cube means 1, this is p, this is q, this is 5, right? 3 cube 27, 9p, 3 cube plus 5, isn't it? 5 get cancelled. Again 9p minus p, 3 cube minus q, isn't it? 9p minus p, 3 cube minus q, and again here 1 minus 27, right? Transfer p and q to that side and transfer this 27 to this side, isn't it? Therefore 9p minus p, 3q minus q, and here 1 minus 27. 9p minus p, that is 8p. 3q minus q, that is 2q, and here 26. You can divide with what here 2. Divide by what here 2. When you divide it with 2, you have got 4p plus q. It is equal to minus 30. This is number 1. Right? Again, the condition of a Rolle's theorem gets satisfied. Therefore, there exists a point C belongs to 1, 3 such that f dash C it is equal to 0. Therefore, you can find out here f of x is equal to x cube px square plus qx plus 5, isn't it? Now find out f dash x. The derivative of a x cube, that is equal to 3x square, that is 2px. Again, the derivative of a qx, that is q, and the derivative of a 5, that is always equal to 0. Therefore, f dash c it is equal to 3c square 2pc plus q, and it is always equal to 0. Right? Now they have given the value of a c, that is 3. Here c they have given as a 2 plus 1 by root 3 whole square. Again 2. P remain as it is. They have given the value of AC, that is 2 plus 1 by root 3 plus Q, it is equal to 0, isn't it? Now again see, here 3 remain as it is. Make the expansion, that is a plus b whole square. 2 square means 4. Again, twice the multiplication of a 2 term means 4 divided by root 3. And here the square of a second term, that is equal to 3. Right? When you multiply with 2p, here you have got the 4p, right? 2 to the 4, and again 2p divided by root 3, right? And plus q, it is always equal to 0. Again, if you observe this, 4 3s are 12. Again 4 3s are 12 divided by root 3. Again this 3 get cancelled 1, right? Again 4p plus 2p divided by root 3 plus q, it is equal to 0. Now can you substitute the value here? There are the 2p, isn't it? Therefore, it is convenient to substitute the value of a q. What is the value of a q? The value of a q, it is nothing but what here? Minus 13 minus 4p, right? Therefore, q is equal to, that is minus 13 minus 4p from first, and put in second, right? Therefore, here you have got 12 divided by root 3. Again 1, or 1 plus 13, you can 1 plus 12 you can write as a 13 plus 12 divided by root 3. Again 4p plus 2p divided by root 3. And here what is the value of a q here? That is minus 13 minus 4p. It is equal to 0. Again, if you observe this, the 13 minus 13 get cancelled, 4p get cancelled, right? Now here you have to multiply with what here? Root 3 throughout, isn't it? When you multiply with root 3 throughout, then root 3 into 0, you will get 0. Therefore 12 plus 2p, it is equal to 0. Therefore 2p, it is equal to minus 12. Therefore p is equal to minus 6, and this is the result. By substituting the value of a p, it is minus 6, in the equation 1, you will get the value of a q also 4. What is the value of a q? That is, what is the value of a p? Minus 6. Minus 6 put here, and plus q, it is equal to minus 13. Therefore, minus 24 plus q, it is equal to minus 13. Q is equal to minus 13 plus 24. Therefore, q is equal to, that is, this is 7 plus 4 11, isn't it? Therefore 13 11, that is equal to 24. Therefore q is equal to 11 and p is equal to minus 6, right? So here you have got the values of, that is, the q, it is equal to 11 and p is equal to minus 6. This is the very, very important example. And here we have finished, that is what here, the Rolle's theorem, isn't it? The condition, so again I will take another example, or it is sufficient. So these are the sufficient examples for what here? Rolle's theorem. So here I have finished, that is the application of a Rolle's theorem and the Rolle's theorem, isn't it? So the student, if you like my video, share it and subscribe my channel, isn't it? And if any comments are there, again please tell me and give your suggestion. Good day for you.